Yeah, hi guys, welcome to the present session. So I hope my audio and video, both these two are fine.
Yeah, hi guys, welcome to the present session.
Yeah, if you're having any problem with my audio and video, then please let me know in the comment section. So before going into the main content of this video, myself I am Aswini Kumar, an academy educator of electronic science as well as the general paper 1. And Unacademy is providing the wonderful online coaching for the UGC NET aspirants of the multiple subjects. Okay, and Unacademy is also providing the free online classes as well as the paid courses. So free online classes you will get on the two platforms. One is on Unacademy UGC NET channel, and another one is on the Unacademy app or the website. So in the description box of this video, my profile link is given. So click on that profile link and then you will be directed to this web page. So first click on this follow button so that you will get all the updates regarding my new courses. And if you scroll down, then you will get the special classes. Okay, so what are the special classes are there? All these special classes are freely accessible by everybody. So these are the free online classes. So here the paper 1 and paper 2 electronic science and few PhD admission guidelines. So all these things are mentioned here. Regarding these things or the topics, the free online classes are there, okay, that you may check down. Okay, and apart from these free online classes, the Unacademy is also providing the paid courses for the paper 1 as well as the paper 2 electronic science. And the electronic science new batch course is going to start from Feb 9th onwards. That means the next month 9th onwards the new batch course is going to start for the paper 1 as well as electronic science. So all the interested candidates may take the subscription plan, and these are the different subscription plans guys. And you may use my referral code, that is ASWINIKLIVE. So it is my referral code and click on the apply. So on any one subscription plan, any one of the subscription plan, okay, or else all the subscription plans you will get the 10% discount, and you may take any one of this plan. Okay, 3 months, 6 months, 12 or the 24 months. So use my referral code to get the 10% discount. It is ASWINIKLIVE, and then click on the proceed to pay. Got it? So these are things guys, and now we will go into the main content of this video. So here the 9th unit, that is the SCR and the control systems. Okay, so regarding this unit, we are going to see the few previous year questions guys. So we are going to start with this question, and whatever the answer you are feeling for this question, I will give the 60 seconds of time, that is 1 minute of time I am giving. So within that 1 minute, please mention your answer in the comment section of this video. Okay, yeah, so what is the answer for this one? Mention your answer in the comment section of this video. So in the forward blocking region of the silicon control rectifier, which of the following statements are correct? What is the correct answer? Hi Krishna. So in the forward blocking region, that means the SCR is still in the off state. So in this region, actually SCR is having the three junctions, J1, J2 and J3. And out of these three junctions, in the forward blocking region, J1 and J3, both these two are in the forward biasing region. Why? Because the anode and the cathode terminals are given as positive and negative to the supply voltage. and but the gate is not connected to any voltage, so the J1 and J3 are in forward bias and the J2 is in still reverse bias condition. So option 2 is the correct one. Once after crossing the forward blocking region, then uh, what will happen is that by increasing the VAK, the J2 will goes into the breakdown condition, and then the huge amount of conduction will starts to the silicon control rectifier. Okay, anyhow here the 2 is the correct. And what is the option for this one? Okay, so for this one here, SCR is connected to 200 volts and the inductance 0.2 Henry. Actually, we are connecting the inductance to the silicon control rectifier. Just a minute. Yeah. So usually we'll connect the inductance to a silicon control rectifier to protect the SCR from the high currents. Okay. So it is to protect from the dA by dTs, right? And if the latching current in the circuit is 3 milliamperes, what is the minimum width of the gating pulse required to turn on the SCR? That means here, so SCR is in on state and the voltage across the inductor V is equal to L into dA by dt, and from this one we can take I is equal to 1 by L integration of V into dt. So I can be taken as 3 milliamperes, that is equal to 1 by 0.2 integration of V is 200 into dt. So 3 milli into 0.2 divided by 200 is equal to T. So from this one how much we will get? We will get 3 microseconds as a correct answer. So option 3 is the correct one. Next, what is the answer for this one? So basically the transfer function can be defined as Laplace of output divided by Laplace of input. Okay, it is the correct one. But what about the initial conditions? We are making the initial conditions as a 0. Okay, so by taking the initial conditions as a 0, we are taking the output Laplace of output divided by Laplace of input. So A is the correct one and B is the wrong one. And error signal is nothing but actually we are taking like this. So whatever the error signal is there, that is the difference between the reference signal and the feedback signal. So C is also correct one. Okay, so A and C options are correct, so we can take first option as a correct one. And coming to the D option is that the input is the dividend by the transmitters to the output signal. Actually, output by input is equal to transfer function, right? So here output, if you want to get the output, then the input must be multiplied with the transfer function, not dividend by the transmittance. Okay, fine. Next, so what about, yeah, before attempting this question, I want to give the few points. The first one is that one automobile system is there. That automobile system is completely under the control of a driver, and the traffic signal is there. Whenever this automobile or the car who is which is completely under the control of driver, whenever this car is coming to the junction, the traffic lights red, green, yellow, it's on and off depending only upon the timer that is set to that traffic system. Timer, that means on and off of the lights of the traffic system depends upon the timer, but not on the intensity of the traffic. Okay, so now, so based upon both these 2 points, here the 5 questions will come. The next 5 questions has to be answered based upon this concept. Okay, the car is under the control of driver, and the traffic systems lights glowing and off based upon the timers, but not on the traffic intensity. Now coming to the first question out of the 5. Following statements are given: automobile system, traffic system, which one is a closed loop, which one is a open loop? So please. Okay, so here we can take that automobile driving system is controlled by a driver, right? So controlled by a driver means it is a closed loop, it is a closed loop system only. Okay, and the traffic system is based upon the timers, it is not based upon the intensity of the traffic. So traffic system is a open loop, so we can take B and D as a correct answer. So option 4 is the correct one. Next, it is the second question. Traffic signal system is what? Traffic signal system is what? So it is an on-off system. Okay, traffic signal system comes under the on-off control system. Why? Because it is not at all proportional to any one of the traffic intensity. Okay, it is simply based upon the timer. If 1 minute I set means after 1 minute it will on, after 1 minute it will off. That's it. So it is on and off control system. Next, In an automobile driving system, the eyes of the driver acts like what? In an automobile driving system, eyes of the driver acts like what? So what is your answer? Please mention your answer in the comment section. So here the answer is visual link to the feedback gain. Okay. So whatever the automobile we are taking, that means if the car is going like this, and if the car is deviating from the original position, then the driver eyes will sense that one, that I am deviating, and again he will take back to the correct directions. Okay. So visual link to the feedback, it will act like. Next, in an automobile driving system, the brain of the driver acting like what? Brain of the driver is acting like what? Yeah, it is acting like an error detector, right? That means it will find out the error, how much amount of deviation is there. Next, in automobile driving system, the function of the actuator. Actuator means the parameters which are controlling the speed of the automobile. Those are called as a actuator. So what is the correct option? So here the answer is both brakes and the accelerators. Both these two are used to control the speed of the automobile, right? So option 3 is the correct answer. Okay, fine. Next, the junction capacitance of a thyristor and the charging current and the dv by dt he is asking to find out. So what is the answer, guys? Yeah. So here we can take I is equal to C into dv by dt, and dv by dt is equal to I by C, I is 5 milli and C is 20 pico. By solving this one, we will get the 250 volts per microsecond. So option C is the correct answer. Next, what about this one? Fine. So here the supply voltage must be greater than the forward breakover voltage. That means whatever the anode to cathode voltage, if it is greater than the breakover voltage, then the junction J2 goes into the reverse bias, junction J2 goes into the breakdown condition, and then the conduction starts. Okay. So for the conduction starting, we can take this one as a correct option. And here we should take that gate voltage we are not giving. And always the latch current is greater than the holding current. Latch current means the current required to on the SCR. Holding current means if the amount of current flowing through the SCR is less than the holding, then the SCR will be in the off state. Okay, so we can take 1 and 4, so option 4 as a correct answer. Next, yeah, leave about this question. Yeah, do this question, guys. Sensitivity. So usually the sensitivity of the transfer function with respect to the forward path, dou t by t divided by dou g by g. Okay, and t is nothing but as a negative feedback one, we will get t as g by 1 plus gh, and from this one we can take that g divided by t into dou t by dou g. And if I differentiate the overall transfer function with respect to g and substituting this one, I will get 1 divided by 1 plus gh. Okay, so now STG is equal to 1 divided by 1 plus g into h. Okay, and in the place of s, I am taking the j omega, and I have to take the magnitude, and in the place of omega substitute the 1 radians per second. Okay, then you will get the answer. So 25 into 0.25, actually 25 and 25 is 625. So 6.25 divided by s into s plus 2. So take the s as j omega and simplify and take the magnitude, and in the place of omega substitute as a 1. So whatever the answer you are getting, that will be the final answer. Okay. Next, what is the steady state error? Please take here the unity feedback as well as the unit step signal as a input. Unit step signal as a input and calculate the answer, guys. So what is the answer? So ESS is equal to limit s tends to 0, s into E of s, right? EFS can be taken as RFS divided by 1 plus G of s into H of s. So limit s tends to 0, s into RFS is nothing but the Laplace, that is input. Laplace of input is 1 by s. So 1 plus G of s, that is 25 divided by s into s plus 5 into H of s is 1. So s and s both these two gets cancels, and in the place of s if I substitute the 0, then I will get 1 divided by 1 plus 25 by 5, that is 1 divided by 6. So 1 divided by 6 means how much I will get? 6 ones. So I will get 0.1 radians approximately. So we can take option 1 as a correct answer. Okay. Next, a very good control system should be what? What is the answer? A very good control system should be okay. It must be insensitive to the parameter variations and sensitive to the input commands. Why? Because, for example, if you are taking a transistor, the output of the transistor must be insensitive to the temperature variations. So temperature variations means it must be insensitive to the parameter variations, but it must be sensitive to the input current. So it must be sensitive to the input command. So here B and D can be taken as a correct answer. So option 3 is the correct one. Okay. Next, which of the following is the correct statement? Which of the following statement is the correct statement? Feedback can increase or decrease the sensitivity. Why? Because if you are taking the negative feedback, what happens? Sensitivity decreases. And if you are taking the positive feedback, what happens? Sensitivity increases. So it depends upon the type of the feedback. We can't tell in a generalized way. So option 2 is the correct answer. Next, what about this one? So sensitivity of transfer function to forward path, and they're telling that it's a open loop control system. Open loop control system means whatever the open loop control system means the overall transfer function and the forward path, both these two are same. If both these two are same, then it becomes as equal to 1. So we can take option 1 as a correct answer. Okay. Next, the value of on-state voltage of an SCR is approximately what? So what is the answer? Exactly. If the SCR comes into on state, then its resistance will be decreases too much, and the voltage across the SCR can be taken as, of course, 1.2 to 1.4 volts, but 2 volts is nearer to this one. Next, what is the answer for this one? What is the answer? SCR is a control rectifier. Xenon diode is a voltage regulator. UJT is a relaxation oscillator. FET is a voltage variable resistor. Okay. So we can take option D as a correct answer. Yeah. What about this one? So SCR holding current, UJT intrinsic standoff ratio, right? So A goes to 4 means obviously only one option is there. So D can be taken as a correct answer. Got it? Yeah. So by this I'm closing this session, and again we will meet on the next Monday. Okay. So thank you very much, Krishna, for joining the session. Bye.